Okay, finally, chapters 50, 52, and 53. Um, so these are the chapters on ecology. So what's really important here is trying to understand, physical, population level, and community level effects or for pressures on on distribution and abundance of species. Okay, so we started off by talking about climate, and for terrestrial systems, really the main drivers are latitude and sunlight, so that translates into temperature, as well as rainfall. Temperature and rainfall are the two big drivers that determine biomes. And so remember what biomes are. These are kind of your large scale habitat types, like deserts and Arctic tundras. Um, so rainfall and temperature define biomes, and then biomes define in turn what plants can be there, what the plant community can be, as well as things such as what the net primary production is. And then those things in turn to define what kind of animal community can be supported in the biome. Um, so in terrestrial systems, temperature and rainfall really are your big drivers. In aquatic systems, we talked about a number of different important factors. Light being the most important. Light determines primary production, and net primary production determines what kind of animal community can exist there. But we also talked about things such as salinity, flow, which affects oxygen penetration, and a couple of other factors that are important for aquatic systems. But again, for terrestrial systems, it's largely temperature and rainfall. For aquatic systems, it's largely light that really kind of set the ground stage for what kind of plant communities and what kind of animal communities can be found. Okay, we then talked about population dynamics, and so you should be able to understand the difference between intrinsic and extrinsic factors, and how those influence or can limit population growth. So the intrinsic factors are factors that are caused by or brought about by the population itself. So as a population grows and the resource basis remains constant, then the resources per capita decrease, which means that that's less resources that can be used to support reproduction and population growth. So that's intrinsic. Okay. Extrinsic factors include all of the outside things such as predation. Predation can control how quickly a population grows, disease or parasitism, competition with other species. So those would all be extrinsic factors. We talked a little bit of, we also did some examples in class that were looking at population growth models. So you should be comfortable with doing some of those type of calculations. If I were to ask you to predict the population size in a geometrically growing population at some defined time, such as 5 years from now, you should be able to do so. You should also understand the difference between geometric and logistic growth, and why most populations ultimately follow a logistic model rather than geometric growth. If I were to define for you something like a carrying capacity for a population, you should be able to use a logistic model and predict population growth. So, again, like the problems that we did in class with raccoons. With communities, we talked about competition and predation. So you're responsible for those sections. We talked about competition from the standpoint of intra versus inter, and you will recognize that interspecific competition tends to be less intense, because when an individual within a species is competing very intensely with other members of its species for basically everything, there's complete overlap in terms of resource need. So intraspecific competition is very intense. Whereas with interspecific competition, a member of species A may compete with a member of species B for food resources but not habitat, for example. So the overlap of resources isn't absolute. It's not a complete niche overlap. And so again, interspecific competition tends to be a little bit less intense. One of the results of competition or interspecific competition can be a niche shift or a niche narrowing. So an animal may have an inherent niche or a fundamental niche. This is basically the resources that it could use or the range of tolerance, the range of habitats that it could occupy. But when faced with a competitor, it may actually narrow its realized niche, and so its realized niche may be much smaller than its fundamental niche. Basically, what that means is you may have two species that are sharing the same range of resources or the same fundamental niche. Okay, so they may overlap with each other, and if species A is a better competitor than species B at low temperatures, and species B is a better competitor at high temperatures, then rather than species A occupying the entire temperature range that it could theoretically occupy, you may find species A only in cold water and species B only in the warmer water. Okay. We also talked about predation, and so with predation, we looked at some examples of specialized predators where you have a predator feeding on a prey item, such as the barracuda feeding on the clownfish. And we talked about some of the models, a Latka Volterra model for predator-prey interactions. So you should be able to solve some of those types of problems if asked to on the exam. Okay, and that's mostly it. So I'm sorry that this is kind of rambling, and I know stringing together this is getting a bit long, but that covers most of the things. Again, if you wanted to sit in on my day class on Tuesday, that meets Tuesday at noon in TRS 1-067. Okay,